Good evening, everybody. Welcome to another vBrownBag. Tonight we are kicking off our new series, Python for DevOps, and tonight is the basics. Joining us tonight is the one and only Chris Williams, Mistwire on Twitter, the legend himself. Chris, say hello.
What? Hello.
Hello. Before we get started, though, I just want to remind everybody that this is an interactive podcast. Please ask us your questions tonight. If you're watching on GoToMeeting, ask us questions in the chat box if you would like. Uh, Feel free to engage with us on Twitter as well using the hashtag vBrownBag. And if you're watching and you feel like your Wednesday nights are too busy and you want to tune in another time, make sure you check out our other shows on other nights. There's the schedule right there on the right hand of the screen. I'm your host, Ken Nalbone, and I will be fielding questions during the evening, so just feel free to ask away, and I'm going to turn it over to you now, Chris.
Huzzah.
All right, change presenter. Okay.
Show my screen. All right, let's make sure that I am showing the correct screen. Can you guys see the presentation screen?
I see your presentation, nice and full screen and pretty.
Yay. All right. So thank you everybody for showing up for this. We're very excited. We here at vBrownBag are kicking off. We've been talking about doing this series for quite some time now because there's been, as you all know, a confluence of events that have been pushing infrastructure people towards code, pushing coders towards infrastructure. And in the middle of all of this, there is this magical unicorn called DevOps. You've got your dev people and you've got your ops people, and the expectation, the thought process is nowadays that that there is some people out there that can do both. They can take 20 years of infrastructure and data center knowledge and mash it together with 20 years of architecture and software knowledge and package all that into a 4-year graduate student who will get paid less than 6 figures. I'm being moderately facetious, but that's kind of the state of the union today. So what we decided to do was we're going to do this this series, and I have a slide on expectation. So let's kick over to that. So does this work? Hello. So who am I? Hi, everybody. My name is Chris Williams. I'm a cloud architect for Green Pages Solutions. I'm very irritating and highly vocal on Twitter. So I'm at Mistwire up there. I do a lot of work in AWS, and that's actually what was the initiator of this entire series was all of the work that I've been doing in AWS for the past 3 years. It's getting a lot codier. So I've also been a vExpert for a while now. I cut my teeth on VMware, so I have a VCIX 5 and 6. I started, on GSX 2.0 back in the day, which tells you exactly how old I am. I also helped to run a couple of different community groups, vBrownBag, of course. I also run the Amazon Web Services Portsmouth user group, AWS Pug, which has an adorable logo of a tiny little pug with AWS on the side. He's super cute. I also helped to run the VTUG. So we just had our Gillette Stadium Winter Warmer last week, and I got to meet Rob Ninkovich, and I have an amazing picture of him too. You can also see me at my blog on mistwire.com. So what I am not a developer. I want to be very clear about that. And as we get into the meat of this presentation, you will see exactly how much of not of a developer I am, because this is Python for non-developers who are learning. I'm in that group with everybody else. If you already know how to do classes and functions, and you have a CS degree and you've been writing code for a very long time, this might not be the class for you. But the good news is the rest of the series will be the right place for you, and I'll get onto that when we get through this. So today we're going to cover, the environment, the resources, and that's literally the most important part of this. So the great resources section, I'm going to go through that a little bit ad nauseum, and then we're going to get into some of the basics: variable strings, booleans, data structures, looping, functions. We are not going to get into version control. We are not going to do any of that stuff. We have covered that innumerable times with 2 seasons of Commitmas, the 12 days of Commitmas, both in what was it, Ken? Was it 2016 and 2017? I forget, or was it 2015 and
I
2016?
think 15 and 16. I think there was no 17, but I could be wrong. It could have been 16, 17, skip 18. The years blend together.
Regardless, there's a ton of Git
all I know
version
is my
controls.
joints creak a lot since then.
Yes, exactly. So we're not going to even go near Git because we already have tons of videos on it. If you want to get into some version control knowledge, I highly encourage you to do it, but this isn't going to be where it's going to be at. Check out the other videos. The format of this series is that it's not going to be contiguous. We are going to have seminars and sessions when the speakers can present. Some of the speakers are in Australia, some of them are in EMEA, some of them are in Oregon and stuff like that. So 8:30 Eastern Standard Time is not good for everybody. What we're going to do is we're going to record them when we can. We're going to post them when we can. Sometimes we'll be lucky and they will happen at 8:30 EST on a Wednesday. Sometimes they won't. But the good news is on those times when it doesn't, we'll actually have some other series running on the 8:30 Wednesday night session slot. So you'll get 2 vBrownBags for the price of 1. Like I said, some of it's not going to be live, and the rest of the presenters that we have, other than myself, because remember I'm not a developer, are actually going to be dev and DevOps people. And the format that we're going to have is going to be a highly operational, highly technical format. It's going to be, here's the problem or task that I ran into in my environment, and go through some of the wherewithal of all of that. And this is then they're going to go, okay, and this is how I solved it using Python. This is going to be like a little bit of the architecture and the data flow, and then we're going to actually do a walkthrough of the code. I imported this function, and this is why I imported it. This is the module that I used, and these are the methods that I called from inside that module. This is what a function does. This is the callbacks. It's going to be advanced, but also basic at the same time, if that makes sense. At least that's my ideal. That's the vision that I have in my head of how this is going to go. And hopefully, I'm sorry, Ken?
Yeah, I was just going to say, we have one question from the Graham. Was wondering how many sessions can we expect in this series?
As many as humanly possible. I currently have 7 presenters lined up. So if they come through, at least 7. I have. There's been an exceptional amount of buzz around this. So there's been a lot of interest in presenting. So more than 7 people have said, yeah, I would love to. I have firm commitments from 7 so far. So
thank you.
Hopefully 7.
Great.
Okay, so where to start? So if you are like I was, and you have no idea what's going on, you will get awash with all of the different recommendations of what to install, what to use, this is the best thing, that's the best thing. Literally, the only thing that you need to get started is Python. Just go to python.org, download the 3.7.2 as of this recording version of it, and run everything from idle. If you want to get into Notepad or Sublime or Atom or Visual Studio Code or PyCharm as your IDE of preference, if you want to use Git Subversion or Code Commit as version control, I don't care. I truly, there has been so much blood spilt over the back and forth of that I'm not going to get into that topic. Do what you want to do. You do you, and I'm going to. So I personally use Visual Studio Code, and I use GitHub to commit all my stuff. I just have public repos. I did just create the first private repo because they just made 3 privates. So I've been moving stuff into my private repos. That's what I use. I happen to like Visual Studio Code. I don't care what anybody uses. I used Notepad++ for the longest time, and that was perfectly fine for me. And before that, I used just idle, and the REPL, and that was perfectly sufficient as well. So that is. Everybody that ideally every presenter that we have is going to have like a different take, a different IDE, so that everybody can get like a broad spectrum view of what's available out there. But yeah.
Yeah, I think it's only a matter of time before somebody chimes in with VI Master Race for their IDE.
Oh, Oh, somebody's going to say Vim, Emacs. Of course they are. That's you know, it's. I should have put a logo up for that. Goddamn, Ken.
Let's end the recording and start over then.
Right. Okay. So this right here is the most important slide. Take a screen cap. Do whatever you got to do. This is the thought process. I have been through a ton of different books. Let me take that back. I've looked at a ton of different books, or I have skimmed a ton of different books, and I'll get into learning methodology here in a second. These courses and these websites are the best of breed in my opinion, but they are the ones that spoke to my brain type too. So Automate the Boring Stuff by Al Swigert. In fact, all of the stuff from Al Swigert, if you go to his website, is super primo. But that book in particular is really good for infrastructure people who just need to get enough under their belt to learn how to like manipulate files or push things into different stuff or do a little bit of web scraping or something like that. He doesn't even get into object-oriented programming in this. There's very little. He doesn't get into list. What's that word that I'm thinking of? Dictionaries and list. I'll think of it later. He doesn't get into the higher level stuff. This book right here is really great for people that want to get into it. They don't need to know higher level stuff, or they just want to know just enough to, figure out how to, take this file that they get on Friday night and instead of spending 10 hours parsing it, figure out how to have a script go through and rip all the data out of it and put it into an Excel spreadsheet. This is a really good one. Modern Python 3 Bootcamp by Colt Steele on Udemy. He doesn't have a Twitter handle. This is the only course on here that, or actually no, this one's also paid for. This is the only Udemy video course on here that is a paid for thing that I'm recommending because it is really that good. There's like 300 or 400 lessons, and each lesson is broken up with actual gradable code options. So he gives you a task that you have to complete in code inside of the website, and there's an auto grader in there that grades whether you did it correctly or not, and it's phenomenal. And it's like, lesson, exam, lesson, exam, lesson, exam, list comprehension. That was what I was trying to think of before. List comprehension and dictionary comprehension. Al doesn't get into list or dictionary comprehension, which is amazing space magic. I'll get into that later too. So Colt Steele, Udemy Modern Python 3 Bootcamp. He's got a really good way of conveying the information, and my brain really worked with this one. Another one that's really fantastic is Python for Everybody by Dr. Charles Severance. I think he's out of the University of Michigan. This is fantastic. This one's free. It also has an auto grader, py4e.com. I first ran into this on Coursera, but then I realized that he also published it on his own website for free. So this is really, really good, especially for for strings, things that you want to do with strings, splitting strings, farming information out of strings. He's got a really excellent section that explains strings to a very, very granular degree. I liked him a lot for that. Python Crash Course by Eric Mathis. That is another fantastic book. What's really good about this one is it's broken up into two halves. The first half is the basics, and the second half is really good meaty projects that have that have good value in them. Much like Automate the Boring Stuff, where you have projects and everything, but this one, he gets into object-oriented programming, list comprehension, dictionary comprehension, classes. He gets into the advanced stuff as well. It's not, so I've put these out in the order that I wish that I would have learned them in. I didn't do these all in order, but this is, if I was going to start over fresh again now, this is how I would do it. I would do Automate the Boring Stuff, then the Modern Bootcamp, then Python for Everybody, then the Crash Course. Excuse me. Code Combat is ridiculously fun. This is a website built for, I think, 6th graders or 7th graders, something like that, and it teaches you Python through like a Dungeons and Dragons scenario where you have heroes, and each piece of gear that you have has different functions and methods that you can call. So like you get a pair of glasses that allow you to see to a certain distance, and then that allows you to call a function called, find nearest enemy. And it starts off very, very simplistic, move left, move right, move up, move down, but then it gets really like, move across the screen, only attack the skeletons, grab coins, but only get the gold ones that are worth more than this. Once you've gotten 25 coins, stop and then go and kill the wizard skeleton. It's really cool, and the way that they do everything is super, super, super repetitive. So they really hammer it home, and repetition is the best way to learn anything, especially a new language, whether that be a computer language or a physical language. Code Combat seriously hammers it home. I actually play this for fun. I'll log into it at night, and for like 25 or 30 minutes, I'll just play it for fun, just to like level up and get my warrior, my wizard, up to the next section or whatever like that. And each character class, you have like warriors and rogues and wizards. Each character class can do different things. So the warriors can swipe and cleave, and the wizards can cast, and the assassins can jump. It's really cool. Then of course there's the actual documentation from Python. So there's a beginner's Python tutorial, which I recommend everybody just go through, and then there's the beginner's guide, which has a ton of links to a bunch of other really good resources in here as well. This right here is really interesting. Talk Python to Me is a podcast by Mike Kennedy, and he's got about he's like on episode 194 right now, and I started listening to it. So a friend of mine, one of the people that's going to be presenting is the leader of the indie Python user group. His name is Calvin Hendricks Parker. He's a really nice guy. He's going to be doing one of the sessions. Super, super smart guy, really loves Python. And he said, start listening to the Talk Python to Me podcast. And I was like, Calvin, I'm not going to understand, 90% of the words. He was like, that's irrelevant. Getting exposed to the words is what's important, and he was right. So I started listening to the podcast. There's almost 200 episodes, so I just picked the ones initially that were just, how to learn Python, teachers teaching Python to sixth graders and what things they used, and methodologies for learning paradigms and stuff like that. And eventually I just started I was right at the beginning. I didn't understand 90% of the words, but I'd remember them, or they'd stick in my head, and I'd go Google them or whatever like that, like what's an F string, and what's a module, and what's an IDE, and all that stuff. And I just had so many questions. But after a while, I listen to it, when I'm driving someplace, and each one's an hour, and it's just so filled with goodness. It's a really good podcast. I'm actually trying to get Mike Kennedy to do one of the presentations here, which would be really cool. That would be really fun. And then Python Tutor. Python Tutor is a website. Actually, I'll just bring it up. Python Tutor is a website that allows you to put code into the interface. I think they're using Sculpt on the back end to execute this. You put your code in here, and then you visualize the execution. And what it does is it allows you to step through the entire process, and it shows you exactly what's happening at each step. This is a very simple for loop, so it's just going back and forth. It's iterating through the range from 1 to 10. And it's using the num iterator to then do a thing to num, and right now it's just print num. But if I had something like iterate num plus num, then you could just add numbers together. But Python Tutor is really fantastic for debugging code for yourself. Like if you've got something and you're trying to make it work and you have no idea why it's broken, you can just throw it up in here, and as long as it's 3.6. If you're doing something in 3.7, like the new dictionary stuff, then it wouldn't work. But as long as it works with 3.6 or below, then you'd be fine. You can go through here and see what the hell's going on, and it's really good for visualizing. Okay, now my variable has changed from this to that. It's this bucket of memory has changed, and oh, that's why it's not working. Okay, cool. So that's what like I said, most important slide. Any questions? Anybody?
No
Not
questions,
even
just a
Graham?
couple comments. Graham provided a link for some of Colt Steele's classes.
Oh, he's so helpful.
If you're wondering who Dr. Chuck is, he's Charles Severance.
Is that the word I'm going to use? Helpful? I'll use helpful. Graham, you're so helpful.
I guess Britton wanted to know how you know what your quote unquote brain type is, and I just told him phrenology will do the job.
Yeah, by the bumps and divots in my head, I can tell that I'm a jerk. So, no, my brain type is I'm fairly stupid. I'll just go ahead and say that out loud. I'm fairly dumb. It takes a long time for me to like get stuff jammed into my head and memorize and everything. So I overstudy and have to have things said to me using block numbers and baby words for a while until I can get the visuals down and like really cement them into my head. These things start off. There's a lot of coding books out there that start off like, here's a variable, here's a string, here's a thing, and then bam, all of a sudden, okay, now we're in the classes, and this is going to be this is how you call a function from the left wing of hell. So I find that a lot of coding books have a really heavy hockey stick like right in the middle of it, in terms of difficulty. These do not. They're fair. They kind of handhold you all the way through the process. That being said, my recommendation for getting into programming, for learning how to program, is pick one book. I don't care which one it is. Pick one book and read the entire thing. Go all the way through, cover to cover, front to back. I mean, skip variables if you already know what the hell a variable is, but go through it cover to cover. Even if you don't get even if there's pieces that you don't get, and I didn't do this for the longest time. I would just get to a point where it got too hard and I would give up, and I wish I hadn't done that. Read it, even if you don't understand it, just read it and grind through it, because the problem with programming is that a lot of the programming concepts depend on one another. So for loops and ranges depend upon each other, and you can't learn for loops unless you learn ranges, and you can't really figure out what a range is until you learn how to implement it in a for loop. And so that there's this chicken and egg thing. So you've got to get one into your head, and then eventually you'll get the other one in. So read one book, and then read the next book, and then read the next book, and then after you've got like 2 or 3 in your head, I would go back and reread the first book again, because there's going to be crap in there that you didn't get the first time that will make a lot more sense after you've got a lot more of the language, a lot more of the dictionary in your head as to what these words even mean. Play with something that gives you a lot of good repetition. I recommend Code Combat, but anything that you can do to keep code in your head, like just read a couple lines every day, or do something to just hammer it home. Keep it in your head, and just stick to a book, move on, stick to the next book, move on, stick to the next book, move on, and then do them again. I'm currently going through Automate for the second time. I'm currently going through Modern Python Bootcamp for like the 3rd time, because that's that good for me. And I always use Python Tutor. So those are my recommendations for learning. Okay, so we're about to get into the meat and potatoes of the basics here. This is when we're going to start talking about all of the data structures and whatnot like that. Before we dip into that, are there any questions about learning? Are there any questions about the process? If there are people that already know the next section, it's not going to break my heart for you guys to drop out. We're going to go through variable strings, dictionaries, the processes of them and everything like that, and it's going to be all of the information that you're going to get out of here. But I'm just trying to collate them into one quick and easy section to get your appetite whetted for programming.
No questions, just a comment. Pick something simple, pick something that's real, and get it working to grind on it when you're getting started with this kind of thing.
Yes, that is absolutely correct. That's actually a really good point. Finding like a little project that you really that is real to you. Like if you have like like if somebody sends you a grocery list and you want to move it over. So my boss has there's a website out there called Pack Publishing, and every 24 hours they give away a free PDF, a free ebook. And he was so lazy he didn't want to go to the website to see what the free book was every day. I just have it set as my homepage, so I just see it every morning. But he didn't want to go to the page, so he used a Python script and used the beautiful soup module to scrape the information out of that, and his Twitter account sends out a tweet to him with the book of the day. So he used Python and Beautiful Soup and the Twitter hooks to tweet to himself the book of the day, and that's how he started getting into Python. Pick a project, find something that's relevant to you, and do that. That's the best way to do something. When you're playing with, like, for loops and you I can print from 1 to 10. Who cares? It's good for a demo, but it's not going to give you the real feel for how powerful this language can be. Okay. With that being said, on to variables. So variables are the buckets that allow you to instantiate stuff. You could call direct data structures directly, like numbers and stuff like that, but without variables, without things to contain them and help you to modify them, you don't have. You know what? I don't need to this is an IT crowd. I don't need to talk about variables, do I? No, I don't. I'll talk about the specifics for Python. So if you Google PEP 8 style guide, you'll see what the style conventions are for variables in Python. The convention for variables is lowercase underscore numbers. Do not start with a number. You can start with a letter or with an underscore. Names are case sensitive, of course. The stylistic conventions, and that's from the PEP 8 style guide. Use lowercase snake case for variables, camel case for classes, capital snake case for constants. Constants being numbers in your code that you do not want to ever change, like the value for pi or something like that. And if you're working in a open source something like an open source module or something like that, and you see double unders for something, that means don't touch it. Otherwise, you'll start breaking things and things will go horribly. So for my examples, I've got message equals hello world. This is our string, or the very first thing that anybody ever does. If you print, you can print this directly, or you can print the variable for it, and it'll give you the exact same. It will give you the exact same thing. You can concatenate strings together. You can package strings into a variable. You can package Booleans into a variable, and I'll get into all the other things as well. By concatenating those two together, you can say first equals hello, second equals world. All together now is the third variable, which is first plus second. And then if you print all together now, it'll give you hello world, and you got to make sure you put your make sure you put your spaces in there as well. And then you'll see that I changed message from a string to a Boolean type to an integer. Python is a dynamically typed language. So there's two different types of languages. There's statically typed languages and dynamically typed languages. In a statically typed language, you specify what the variable type is going to be. So if you want your variable message to be string, in your code, you say this variable is going to be a string, and then this is the body of the string. That's so that during compile time, your code is checked, the variables are called and placed into the proper memory buckets, and then the code runs. Python is a dynamically typed language, which means that your variables can change on the fly during runtime. So message can be string for the beginning part of it, and you can change it to a Boolean, you can change it to a 1, you can change it to a list, you can change it to whatever. Because Python is munged at runtime, that is that's why it's dynamically typed, and that's also why it runs slower than statically typed languages, which compile before they actually run. Which makes it very versatile, which makes it very cool. But it also, again, it makes it a little bit slower than your traditional statically typed languages. I don't do anything performance-wise where that becomes an issue for me, so I don't worry about that. And I really like Python. And they're actually making it more and more efficient. So in version 3.7, they changed. Well, actually, I'll get into that later when I get into dictionaries. Okay, any questions? Too slow, too fast, just right?
Quick question. So are there any special characters that need to be escaped, or are there no other special characters that can be used when naming variables?
So when naming variables, all you can use is numbers, letters, and the underscore. You cannot use special characters.
All right, thank you.
Did that answer the question? Because you said escape, so we're talking about escape characters?
The question was any special characters that need to be escaped, and I'm assuming that this is in reference to what you were talking about when naming variables. So
okay.
The answer is no special characters except underscores can be even used when naming a variable.
Gotcha. Okay. Yeah, I mean, there are escape characters for the bodies of strings and stuff, but not, actually, I'm not even going to get into that. That's in the books. So no, there's, for variables, numbers, letters, underscores, no special characters. Okay, cool. On to strings. Let me close this window. So strings, they're a sequence of Unicode characters. They are always held in either a single quote or a double quote. So this is a variable that I have instantiated named Chris Williams. You'll notice that there's 2 spaces in front of Chris and 2 spaces after Chris. That counts, white space counts as a string, as a piece of the string. You can use single quotes or double quotes to instantiate your string, but you have to be consistent across the string. So this string has double quotes, this string has single quotes. You can't have a string that starts with a double quote and ends with a single quote. The reason for that is sometimes you want to do something where you have a, let's say Chris's something or other. Say you want to like show possession and you want to have a apostrophe S in here. You have to have, if you had single quotes on the outside like this, the string would actually end right here. So whenever you're doing something where you're like quoting somebody and you want to have it in quotes, you'll vary your outside quotes to be the double quotes or the single quotes, and then you'll vary the inside one to be the single quotes or the double quotes, or vice versa. That made sense, right? Did what I say just make sense? Ken, you still there?
I can't speak for all of our attendees, but I understood.
Are you asleep? Okay, good. All right, I'll get into this more in the list section, but strings are indexed. So you can actually think of a string as a list. It's got an index, and the 0th index is, or the first index is actually 0. The second index is 1, the third index is 2. So if you're trying to split a string, or you're trying to manipulate the string value or do something with it, you can actually count through. So there's a number of ways to manipulate strings, and to get into all things string, Dr. Chuck's Python for Everybody class is amazing. He literally spends like 3/4 of the time talking about how to like import files, grind through the string, grind through each line of the string, and talk about all the different things that you can do with strings. I'm not even going to do it justice, so I just say see Dr. Chuck's videos because they're phenomenal. He doesn't get into F strings because the version that he was on, I think when he recorded the videos, was 3.4 or 3.5, and F strings came out in 3.6. Yeah, so so strings are indexed. If you're looking at a string and you want to like pull a character out of the body of it, or if you want to search for it, there's a ton of different methods wherein you can do that. If you want to change everything to uppercase, so say like if you're looking for a password or you're trying to strip stuff out of it, or you're trying to manipulate the data, you can use the upper method to capitalize everything, the title method to just capitalize the names. You can use the strip method. There's rstrip, lstrip, and strip, and that will clip the white space out of the sides so that if you're trying to sanitize inputs for like a database or you're trying to move data from one thing to another thing, you can use all of these types of methods, and there's a ton more. There's so many things, so many ways that you can manipulate strings. It's crazy. You can use that to do that. Back to the talk about if strings are indexed, you can actually take the variable and call out the index section of the variable to get pieces of it. So if you want to know what the third character is in your arc, so 0, 1, 2, 3, that will return an H. So if you're trying to, like, go through your environment and see what the last word is or the last letter is in your environment, you can use your index functions to pull information out of strings. So just to reiterate, a string 8 is not the same as the numerical 8. If you take an 8 and you put quotes around it, that becomes a string. And if you're trying to glom together strings, if you're doing string concatenation, you need to be careful because you cannot concatenate strings and ints or strings and floats. They have to be the same thing. And that used to be a little bit more of a pain back before F strings came about, but now it's magically delicious. So for example, if you take a variable and you create the variable year, which is an int, and then you want to, previously what you had to do was you'd have to take this, if you wanted to print something out or do something with that int, you would say string plus, then take the int, cast it as a string so that it could be conglomerated together or glommed together, and then it would get the year is 2019. Now with F strings, you can actually just pop a little F in the front of it, throw your variable in there, and it modifies it for you. So it looks cleaner, it's easier to work. There was also this other concept where you could use the format, which was even worse than casting it. But this was easier for larger programs. Again, F string's awesome. To get really into the weeds of strings, Dr. Chuck's classes are fantastic. Okay. Anything on strings?
I agree. F strings are F awesome.
Oh, I knew somebody was going to say that. Go, Ken. I'm so proud of you.
I had to get that in there. Yeah.
I would have been disappointed if you hadn't. All right. So Booleans and conditional logic. Booleans, true and false values. For non-programmers, when I first saw Booleans, I was like, yes, okay, 1 or 0, whoop-de-doo. True and false values are literally the bedrock of all things. Boolean and conditional logic is how you run the world in programming. It's used in for loops, it's used in while loops, it's used everywhere that you want to do anything. So true and false values. There are certain things that are inherently truthy, and there are certain things that are inherently falsy. So the number 0 is inherently falsy. So if you've got a piece of code and you're trying to prove truthiness of it, then and you say, so like if you say while 0, that actually gives you a false and in a while string, and I'll get into while strings in a second too. See, this is what I was talking about. There's so many things that you have to know the other things, that when you start talking about one thing, it immediately like bleeds over into 17 other different topics, and that's why you just kind of have to grind through it to get it in your head. And then once you've, I don't want to say it's rote memorization, but in certain respects it kind of is. You just have to know that 0 and empty objects are inherently falsy, and that everything else, 1, strings, dictionaries full of stuff, are truthy. And then you can actually use that in a for loop. But then you have to know what a for loop is. So just remember that empty objects, zeros, and none, the value none, are inherently falsy, and everything else is inherently truthy. And when I say empty lists, I don't mean a list with the number 0 in it, that's actually has a value and that's truthy. I mean a list that is literally just an open bracket and a closed bracket. Okay, so conditional logic, or so, hold on, truthy. So comparison operators, you guys should know this. Equals is your equals. A single equals is a variable assignment operator. It does not mean equals. Age is 25 means the variable age is the number 25, the integer 25. If you want to compare values, 25 is equal to 25, you would have to use the double equals. This bang equals means not equals. So 13 is not equal to 25. That resolves to a true statement. Then we have greater than, less than, greater than or equal to, less than or equal to. And then we have your logical operators and or not. So conditional logic means if something is true, then do something based upon that true statement. Else if this resolves to false, it then immediately falls into the next layer of the else if. Check for the truthiness of that statement. If that statement is true, then do this and then kick out. Else do the default action. I said that horribly. Let me try to reiterate that again. The way that if else statements work is it has a series of checks and they happen in order. So if the first check resolves true and it does this thing, it then immediately comes out of the if statement of the conditional logic. It doesn't go through the elif, it does not go through the else. It has to go false, false to bang to get to the else, or if it goes false, true, then it'll do this something else. But it's one of these things, but not anything else. That sounded terrible. Ken, did that make sense, or was that a complete whiff on my part?
I'm with you so far. Let's step back real quick. We have a question though about empty objects. Somebody's asking, is there a concept? Two-part question. Is there a concept of null and empty being different? And kind of the follow-up question is an empty list a null? Does that make sense?
Yeah. So null and none are the same thing. None in Python is null in I think Java. I can't remember. So those are the same two concepts across languages. That is different from an empty object. An empty object is literally, let me see if I have one. So this right here is an empty object. Open bracket, close bracket is an empty object. A none value is actually this word, none. So you can return an empty object, you can return a none, but those are not the same thing. Those have two different values in Python. And what was the second piece of that question?
It is an empty list a null?
No, an empty list is not a null.
All right, thank you.
Cool. All right. Okay, and so then down at the bottom here we have logical operators, the and, or, and not. So in an if, elif, else stack, you can check for the truthiness of a statement, but what you can also do is you can check for the truthiness of multiple statements. So in this if statement, if 5 is greater than 3 and 2 is equal to the string Steve, do something. This is false because both of these statements are not true. You can use the or statement, which means that either one of the statements has to be true. So if one is true and one is false, it's true. But if both are false, then it resolves to false. So you have to have it's either or. And then there's the not, which doesn't actually have it's not a double comparator. It's a single comparator. You can use the not in front of a variable to say like, so age greater than 42 true, not age, excuse me, less than, age less than 42 true, not age less than 42 false. So you use that when you want to invert the truthiness of something. And I don't really have a good example for that. I know that there's a bunch of really good examples out there, but I couldn't think of one off the fly. Yeah, so like I said, a lot of this stuff there's literally entire chapters dedicated to each one of these things in the books that I mentioned before. So this is a very, very high level, very fast, highly incomplete introduction to these things. Okay. So now we're going to get into a couple more of the data structures. These are a bit of the more advanced data structures, but these are the bread and butter of programming. You've got lists, you've got dictionaries, you get tuples and sets, and I'm going to get into each one of these individually. So a list is one of Python's most powerful features available to beginner programmers. I'm going to get into a little bit of the list comprehension stuff down here, but basically what it is, it's an ordered collection of items. So a list is, 1, 2, 3, 4, 5, 6. This particular list right here is an integer, a string, an integer, a dictionary, another list inside of that list, another string, and a Boolean value. And my boss was actually supposed to be watching this, so let me see if he's on. He's not on, so this joke has fallen flat. Dadgummit. All right, I'll make sure that Jonesy sees this. I put a little false back here in the back of it because he's not a jerk. He's actually really nice. So, like I said, an ordered list of items. It's very important that you remember that lists are ordered. So lists are indexed. So remember back when I was talking about strings and in the indexing of strings, lists are indexed. So the index starts at 0. So if you say my list 0, actually here we go, my list 5, it will pull the 5th element out of the list. Now note that the dictionary and the sublist are also count as one element in the environment. You have, if you pull out 4, it'll actually pull this list out. It won't pull out the first bit of this list. If you wanted to pull out a sub piece out of this sub list, you'd actually have to have another bracket with another call to the list inside of the list. They're extraordinarily powerful, and I really didn't want to get into nested lists or nested dictionaries, but just know that those things exist, and when you get into it, it becomes really, really cool, because then you can have 3D data points and really, really cool data structures. The basic format of a list is it starts with an open bracket, it ends with an open bracket, and all of the values are comma separated. The index starts at 0, and lists and for loops. So wherever you see a list, you're probably going to see a for loop too, because lists and for loops are like peanut butter and jelly. When you use a for loop, you can iterate through the list, you can do stuff to the different pieces of the list. And there are a number of methods that you can call to manipulate lists. You can append more items to the end of your list. You can pop items off the end of the list. You can insert things into the middle of it. You can search things. There's tons of stuff for lists. Again, going back to the books, there's more than one chapter devoted to lists because, like I said, it's very, very powerful. List comprehension, voodoo space magic. This line right here literally takes 5 lines. If you don't use list comprehension, then this would take you about 5 lines of code to do. You can do that within 1 line. I'm not even going to talk about it. Just remember list comprehension. Which one has a good one? Oh, Colt Steele. Colt Steele's classes on list comprehension are fantastic. He really hammers home both list comprehension and dictionary comprehension so that you get a really good feel for exactly how powerful this is. You can do all kinds of crazy stuff with, so the concept of a list is you've got your for and your in. Hold on, wait, am I getting ahead of myself? I'm getting ahead of myself. Scratch that. Yeah, scratch that. Okay, on to dictionaries. Wait, before we go on to dictionaries, any questions about lists?
No questions, keep going.
All right, dictionaries. Dictionaries are key value pairs. So lists are very powerful and very amazing, but they're also limited in that all you have is one value per thing, and you don't have, other than the index and the ability to sort it, you don't have a way of going in and finding all of the people named Sally or something like that. And that's where dictionaries come in. Dictionaries store data in key value pair formats. They used to, well, I'll get into the order thing in a second. They start and end with a curly braces. So lists started and ended with the straight brackets. Dictionaries start and end with curly braces. And then everything in here is going to be key, colon, value, and then comma. So it's two discrete pieces of information separated by a colon. Most of the time, the key or the value is either a string or a number, but the value can be literally anything. It can be Boolean, string, dictionary, all kinds of stuff. When I was talking about nested dictionaries, this happens a lot. You'll see the name of something, and then I guess the classic. What's a good classic example? Car. So if you have a car, you have the name would be Audi, and then for the engine parts, you could then have another dictionary inside of here that has a list of all of the engine parts. Their dictionaries are really, really cool. As with lists, you can pull information out of a dictionary using specific calls. So, but when you're in a list, when you're calling it from the index range. In a dictionary, you're calling it by the key pair, and the key pair then spits out the value. And there's a number of ways that you can manipulate it. You can actually change information in here. So in this one I had, my dictionary, name Chris is funny, false, haha, location USA. You can call name, and that'll spit out Chris. You can go my dictionary location equals now Japan, and that will change the value in here so that if you then recalled this dictionary, your location would then change, would have been modified to Japan. You can add additional values to the end of the dictionary. You can pull all of the values out of the dictionary. You can pull all the keys out of the dictionary. You can pull both the key and value pairs out of the dictionary. So here's a good for loop. For info in my dictionary dot values. So what this does is this references the dictionary value pairs, and then it iterates through, and it uses this as a variable to then perform an action on the variable, which in this case is print. So almost always numbers and strings, values can be anything in the dictionary. Provide key to the value. Loop over dictionaries. Oh yeah, and then dictionary comprehension, more space magic. What else was I going to say about this? Oh, for value pairs, you can use numbers, and for the key, you want it to be anything that's immutable. So numbers, strings, and tuples, and I'll get into tuples here in a second. Numbers and strings are immutable. Tuples are also immutable. You want it to be, you can't, for your key value, you can't have like a list or something that you could modify or change or something like that, which if you think about it, it makes sense. You don't want your key to be changing because that's literally the only way that you can access your value here.
So I think that might answer a question we got, which was asking, when you're adding a key value pair, can you specify both by using variables?
No, you cannot. So a variable would be because it's dynamically typed, a variable would be mutable. So you could not use a variable. Is that, you know what? I'm not sure. I think the answer is no, but I'm not 100% positive. Tuples can be used key. It has to be any immutable type. So dictionaries can be indexed by keys. I'm literally looking this up as we go. I'm going to say the key. So the key has to be immutable. So I'm assuming the key cannot be a variable. I cannot answer whether or not the value can be a variable. I would test that. I would create a dictionary and then create a variable, create a dictionary with a variable in there and see if that worked. That's an excellent piece of homework assignment for the asker to install the REPL and test that theory out. Who asked that?
That was Graham, and Larry
Oh,
just
of course
chimed
it was.
in saying keys can be variables.
Really? Keys can be variables.
That's what Larry's telling us.
All right. Well, you know what? When we get an actual programmer in here, we'll have Larry back on, and those two can go at it. I'm not. I don't know enough about that to say whether or not that's true or not. My dict var value, if that is the question, var WTF, maybe homework for Kristen. Graham's such a smart ass. All right, on to tuples and sets. So tuples are similar to lists with the exception that you cannot change the values inside the tuple once it has been defined. They start with an open paren, they end with a closed paren. They are comma separated values, and it's individual values. So they look like a list except for the fact that they got parentheses on the other sides of them. Because they are immutable, once you've created it, you can't do anything to it. There's only two built-in methods that allow you to view, so count and index. Count returns the number of times a specified value occurs in the tuple, and index searches the tuple for a specified value and returns the position where it was found. So you can do some minimal things to tuples. Why would you use them? So if you have like a coordinate plot point and that thing never changes, basically anytime you have a piece of data that you want to never change, you would use a tuple for it. Tuples are very fast because this is a dynamically typed language. If you hard set something and Python knows that you're using a tuple and that it doesn't have to do any extra thinking around it, it can grab and use that information very, very quickly. So if you are in a position where you have a piece of data that's never going to change, then you would want to use a tuple because it actually speeds up the programming. I'm not a programmer, so I don't have a use case in my head as to, oh well, this would be the best place to use it. Sets are very similar to they're kind of a cross between a tuple and so they're not ordered, so they're similar to dictionaries. They're comma separated values, so they're a little bit similar to lists, but you're not allowed to have duplicate values inside of a set. So, and also, unlike a dictionary, there's no key value pairs. So if you took a set like 1, 2, 3, 3, 3, 4, 5, 5, it would resolve to a set of 1, 2, 3, 4, 5. The use case for using a set is when you want to keep a track of a collection of items, but you don't care about order or key or values or duplicates. So if you're, for example, if you're like, when we did AWS Community Day, we had everybody respond to a questionnaire with their zip code. So having that, we didn't for a certain piece of the information, we didn't care about how many people came from the zip code. We just want to know how far away people were from. So when we glommed that together, we just had a list of all of the zip codes. We ran that list through a set and then changed it back into a list, and that gave us just one set of values of all of the discrete, unique zip codes that we had. So that's the kind of use case that you would have for sets. Looping, I actually had loops in the previous section, but I didn't really get into the why and the wherefore of it, so we're gonna do that now. So for iterable objects like lists, strings, and ranges, you can run a for loop against it that allows you to do a thing against that iterable object. So the keywords in a loop, in a for loop, is the for, a random variable name. It can be item, it can be num, it can be whatever you want it to be, in, and then the iterable object that you are trying to go through. So again, this can be a list, this can be a string, this can be a range. And that was actually the example that I had in the visualized Python. So for num in range 1 to 10, print the number. That's what a for loop allows you to do. Again, a very powerful looping structure that allows you to go through information within a program. A while loop is similar to a for loop, with the exception that you have to satisfy a truthy condition, and you have to do a little bit of work ahead of the loop to make sure that you don't get stuck into an infinite loop. So you do need to do a little bit of setup. If the condition never becomes false, it will continue forever. If you are iterating, don't forget to increment or decrement the iterator. My example here is I've created a variable asking for user input, what's the password? The while loop comes in here. While the message does not equal the string abracadabra, print no, and then reprint what's the password. So this will recycle over and over and over and over again until you type in the words abracadabra. Once you have printed the word abracadabra, it'll kick out. It'll resolve to true, which is not true, which is false. So it'll then kick out of the while loop and then print open sesame. So that's for loops and while loops. Obviously, there's a ton more into all of that, so I almost cringe to ask, are there any questions? There are questions. Of course there's questions. Graham, what's your question?
You didn't have any questions on loops,
Nothing?
believe it or not.
Son of, seriously? Graham, come on, bro. I'm almost upset. I'm not. Okay, so functions. This is also a giant. So this is getting into, this is some, I'm not going to say advanced, but this is like more of the intermediate stuff. A function is a block of code that usually does one specific job. And say you've got a program where you have to do something over and over and over again. You don't want to have a long piece of code that repeats, do something, then this, then do something, then that. What you can do is you can create a function that you can reference back to in the code to do that task for you over and over again. So it's basically write once, call it as many times as you need. The body of a function is there's the def word that is the start of the definition of the function, the name of the function. If you have any parameters that you want to pass into the function, then they would be listed here. You can have 0 to several functions in here. I'm not going to get into star args or star or keyword args or anything like that. That's way, yeah. Then in the function itself, you would then do something. If you have parameters, you would take those parameters and do something with the parameters, and then you would either return a value or not, or maybe not return a value, and that would be, this is the definition of the function here. And then in the body of your code, you would then call the function by saying the name and then passing in the arguments that would feed into it. So the parameters are up here. The arguments would be like the numbers that you would pass into it. So the example, the very basic example is defining the function, and the function name is hello. The parameters for hello are the words first and the word last. These are not strings; these are actually parameters that you pass stuff into. When you're creating a function, you always want to have a triple quote. What's the name for that thing? I forget the name of that. So this gives this basically a define. It's documentation on what this function actually does, and then you have the body of the function itself. Oh, so it's, sorry, I forgot about this part. Define, name, open paren, parameters if you have any, close paren, colon, and then when you hit enter, you'll have it'll kick in, either it'll give you 4 spaces and then the something. I forgot to mention this. Python is very space sensitive. So when you're creating code in Python, if you don't have the correct number of spaces in your function calls or your for loops or something like that, it will bork out. So if you say for num in range colon, if you hit enter, it spaces itself appropriately. But if for some reason you do something stupid like this, and then you hit visualize execution, it'll crap out. It's supposed to crap out. It's not crapping out on me. I don't know why that's not crapping out. If you do this in the REPL, this actually fails. I hate live demos. Okay, never mind. This is supposed to crap out. It didn't crap out. All right. Okay. I was trying to talk about case sensitivity. That Python tutor proved me to be a liar. Okay, back to functions. Define, definition, hello, first, last, a simple greeting, print, f-string, hello, last, first, based upon the f-string demonstration that we gave before. This is taking the variable or the parameter last and inputting it from there to here. And then this is taking the parameter from here and inputting it there. So when you then call, so this by itself does nothing. If you create a function, it won't do anything until you actually call to it. So in the body of the code, you would then say hello, and then you would pass in 2 strings, Ken Nalbone. This would then go into, so when you then call the function, it's passing these arguments into these parameters. So Ken goes into first, and Nalbone goes into last. So then when you say hello, or when you say print f-string hello last comma first, this actually prints out and says hello Nalbone comma Ken. And that's the basics of a function. All right, this slide was so important, I had to do it twice. If you guys have any questions about this afterwards, I'll be glad to give you the links. I'll probably make sure that we put this in the video too, that all these links are in the body of the at the bottom of the video as well. So, any last comments, questions, queries to the non-programmer?
I'm sure there are always numerous questions and comments. Graham wanted to know, how do you specify the end of a function definition? Does it basically just have to do with the indentation you were talking about? That last part was me asking.
No. So to end a function, basically what you do, here's the REPL. I'll just do it here. Def my func. Last. Yeah, actually, wait a minute. I'll just cut and paste. Lazy. So when you hit enter and then it gives you the second line, then use this as the body of it. So when you hit enter here, that gives you the second line inside of the function. To escape the function, to get out of it, you just basically hit again. That gets it out of it in the REPL. If you're in an IDE and you want to escape the function, you just go back in the lines. So oh, here we go. I got a function right here. So if you want to get out of this function, if you hit enter, it'll come back again. Hit backspace, and then you escape the function.
Very cool.
Does that make sense?
It does.
Okay. So since we're here, let's call the function hello Ken Nalbone. Oh, see, almost screwed that one up. And then it comes back. So it passed it in. And the order is very important in a function. So whatever you have here goes into the first parameter. Whatever you have here goes into the second parameter. I'm not going to go into there's ways to get around that, but just know that that order is important, which is why I inverted it here, because you can actually take these and do whatever the hell you want to within the body of the function. And with that, hold on, I gotta show my last little. There's that, and then there's the quit. So whenever you want to escape the REPL, you just type in quit, open, close, paren. It's a little method, and it closes it out for you. Holy mackerel! Did that actually go an hour and 10 minutes?
You did. Man. Congratulations. This is great. Thank you very much, Chris.
Yeah, that was super fun.
Even
Let's
if it's
see.
basics, it is not lacking in great information.
So it's it's like I said, it's one of those things where you're going to read a book and you're going to be lost, and then you're going to watch somebody's Udemy videos and you're going to be like, okay, I remember that word from previously. I think I can piece these things together. What I really liked about the Colt Steele Modern Python 3 Bootcamp was all of the demonstrations and everything in there. Let me actually bring it up real quick. You guys can see it. Oh yeah, here, check this out. I went bananas the other day and I just bought like a ton of Udemy courses. Overkill. They were all on sale, so I was like, I got them all for $5. So it's basically like intro, then exercise, then intro, then exercise, then then let's talk about loops, and then have an exercise. It's very exercise heavy. You then punch in the information. You then click check solution, and if it fails, it'll give you a little bit of a reason why it failed. If it works, it says your solution is correct. But then the cool part is you then go into the solution section. It explains kind of what you should have done, and then if you go into the Q&A, you have like literally everybody else's solution in here as well. They're like, I tried it this way, why didn't this work? And then there's a lot of back and forth from the other students, and I've seen a lot of really clever different ways to do things in here. So I really highly recommend the Colt Steele videos for people that think like me, which is literally nobody. So never mind, ignore me.
Very cool. Thanks, Chris.
Cool.
There's no more questions. We're looking forward to more in this series, and thank you very much for kicking it off with us tonight.
I am looking forward to hosting a whole bunch of real developers and asking them a bunch of questions. It's gonna be great fun.
Awesome. Thanks. And I'm going to hit stop recording now.